as you mentioned, like folding a box, folding different articles of laundry, cleaning up a table, making a coffee, that sort of thing. And that's good. Like that works. I think that the results we've been able to show are pretty cool. But again, like at the end, sometimes synthesis, to be clear, is just as difficult as coming up with like profoundly new stuff, right? So I think it's intellectually a very deep and profound problem, and figuring that out is going to be like very exciting. But I think we kind of like know like roughly the puzzle pieces, and it's something that we need to work on. And I think if we work on it and we're a bit lucky and everything kind of goes as planned, I think single digit is reasonable.
What we're witnessing here is the dawn of a new era, one being shaped by Sergey Levine, the brilliant co-founder of Physical Intelligence. His vision is nothing short of revolutionary: to create robotic foundation models, AI systems capable of controlling any robot, performing any physical task, and learning just like humans do. Think about that for a moment. Robots that don't just follow instructions, but truly understand their surroundings. Folding laundry, cleaning kitchens, organizing rooms. These are no longer futuristic dreams. These are the first signs of genuine physical intelligence emerging in the real world. Levine's team is laying the groundwork for robots that can generalize, meaning they don't need to be reprogrammed for every task. Once trained, they can walk into a brand new home, identify objects, and act intelligently. It's as if we're witnessing the creation of a GPT for the physical world. Just as language models transform digital communication, these robotic models are set to transform how humans interact with the physical environment. And here's the exciting part. This is only the foundation. These are the baby steps toward a future where machines can assist, adapt, and even anticipate our needs. The fundamentals are in place. The engine of progress has started humming. Now, what happens when this intelligence begins to scale and learn at human speed or faster? That's where the next chapter begins.
I'm wondering if you can give the audience a summary of where physical intelligence is at right now. You guys started a year ago.
Yeah.
And what does the progress look like? What are you guys working on?
Yeah, so physical intelligence aims to build robotic foundation models. And that basically means general purpose models that could, in principle, control any robot to perform any task. We care about this because we see this as a very fundamental aspect of the AI problem. Like the robot is essentially encompassing all AI technology. So if you can get a robot that's truly general, then you can do, hopefully a large chunk of what people can do. And where we're at right now is, I think we've kind of gotten to the point where we've built out a lot of the basics. And, I think those basics actually are pretty cool. Like they work pretty well. We can get a robot that will like fold laundry and that will go into a new home and like try to clean up the kitchen. But in my mind, what we're doing at Physical Intelligence right now is really the very, very early beginning. It's just like putting in place the basic building blocks on top of which we can then tackle all these like really tough problems.
And what's the year-by-year vision? So 1 year in, now I got a chance to watch some of the robots, and they can do pretty dexterous tasks, like folding a box using grippers. And it's like, I don't know, it's like pretty hard to fold a box, even with like my hands. If you got to go year by year until we get to the full like robotics explosion, what is happening every single year? What is the thing that needs to be unlocked, et cetera?
So there are a few things that we need to get right. Dexterity obviously is one of them. And in the beginning, we really wanted to make sure that we understand whether the methods that we're developing have the ability to tackle like the kind of intricate tasks that people can do.
Yeah.
So as you mentioned, like folding a box, folding different articles of laundry, cleaning up a table, making a coffee, that sort of thing. And that's good. Like that works. I think that the results we've been able to show are pretty cool. But again, like the end goal of this is not to fold a nice t-shirt. The end goal is to just like confirm our initial hypothesis that like the basics are kind of solid.
Yeah.
But from there are a number of really major challenges. And I think that, sometimes when results get abstracted to the level of like a 3-minute video, someone can look at this video it's like, oh, that's cool. Like that's what they're doing. But it's not. Like it's a very simple and basic version of what I think is to come. Like what you really want from a robot is not to tell it like, hey, please fold my t-shirt. What you want from a robot is to tell it like, hey, robot, like you're now doing all sorts of home tasks for me. I like to have dinner made at 6 p.m. I wake up and go to work at 7 a.m. I like to do my laundry on Saturday, so make sure that's ready. This and this and this. And by the way, check in with me like every Monday to see like, what I want you to pick up when you do the shopping. Right. Like that's the prompt. And then the robot should go and do this for like, 6 months, a year. Like that's the duration of the task. So it's ultimately, if this stuff is successful, it should be a lot bigger. And it should have that ability to learn continuously. It should have the understanding of the physical world, the common sense, the ability to go in and pull in more information if it needs it. Like if I ask it, like, hey, tonight, like, can you make me this type of salad? It's okay. You should like figure out what that entails. Like, look it up. Go and buy the ingredients. So there's a lot that goes into this. It requires common sense. It requires understanding that there are certain edge cases that you need to handle intelligently, cases where you need to think harder. It requires the ability to improve continuously. It requires understanding safety, being reliable at the right time, being able to fix your mistakes when you do make those mistakes. So there's a lot more that goes into this. But the principles there are you need to leverage prior knowledge and you need to have the right representations.
So this grand vision, what year, if you had to give a median estimate?
Yeah.
Or 25 percentile, 50, 75?
I think it's something where it's not going to be a case where we develop everything in the laboratory and then it's done. And then, come 20, 30 something, you get a robot in a box. I think it'll be the same as what we've seen with AI assistants, that once we reach some basic level of competence where the robot is delivering something useful, it'll go out there in the world. The cool thing is that once it's out there in the world, they can collect experience and leverage that experience to get better. So to me, like what I tend to think about a lot in terms of timelines is not the date when it will be done, but the date when like the flywheel starts, basically.
Right. Okay, so when does the flywheel start?
I think that could be very soon. And I think there's some decisions to be made. Like the trade-off there is the more narrow you scope the thing, the earlier you can get it out into the real world. But soon as in like this is something we're already exploring. We're already trying to figure out like what are like the real things this thing can do that could allow us to start spinning the flywheel. But I think in terms of like stuff that you would actually care about, that you would want to see. So I don't know, but I think that single-digit years is very realistic. I'm really hoping it'll be more like 1 or 2 before something is like actually out there, but it's hard to say.
And something being out there means what? Like what is out there?
It means that there is a robot that does a thing that you actually care about, that you want done, and it does so competently enough to like actually do it for real people that want it done.
We already have LLMs which are like broadly deployed, and that hasn't resulted in some sort of like flywheel.
That's right.
Like at least not some obvious flywheel for the model companies where now Claude is like learning how to do every single job in the economy, or GPT is learning how to do every single job in the economy. So why doesn't that flywheel work for LLMs?
Well, I think it's actually very close to working, and I am like 100% certain that many organizations are working on exactly this.
Right.
In fact, arguably there is already a flywheel in the sense that not an automated flywheel, but a human-in-the-loop flywheel where everybody who's deploying an LLM is, of course, going to look at what it's doing and it's going to use that to then modify its behavior. It's complex because it comes back to this question of representations and figuring out the right way to derive supervision signals and ground those supervision signals in the behavior of the system so that it actually improves on what you want.
Mm-hmm.
And I don't think that's like a profoundly impossible problem. It's just something where the details get like pretty gnarly and challenges with algorithms and stability become pretty complex. So it's something that's taken a while for the community collectively to get their hands around.
Do you think it'll be easier for robotics, or just that like the state of this kind of techniques to label data that you collect out in the world and use it as a reward will just the sort of like the whole wave will rise and robotics will rise as well? Or is there some reason you think robotics will benefit more from this?
Yeah, I don't think there's like a profound reason why robotics is that different, but there are a few small differences that I think make things a little bit more manageable. So especially if you have a robot that's doing something in cooperation with people, whether it's a person that's supervising it or directing it, like there are very natural sources of supervision, and there's a big incentive for the person to provide the assistance that will make things succeed. Mm-hmm. There are a lot of dynamics where you can make mistakes and recover from those mistakes and then reflect back on what happened and avoid that mistake in the future. Mm-hmm. And I think that when you're doing physical things in the real world, that kind of stuff just happens more often than it does if you're like an AI assistant answering a question. Like if you answer answer a question and just like answered it wrong. It's like, well, it's not like you can just like go back and like tweak a few things. Like the person you told the answer to might not even know that it's wrong.
Right.
Whereas if you're like folding the t-shirt and you messed up a little bit, like, yeah, it's pretty obvious. Like you can reflect on that, figure out what happened and do it better next time.
Yeah.
Now, Sergey Levine takes us deeper into the journey, the flywheel moment of robotics. Imagine a future where robots don't just execute simple commands, but continuously learn, improve, and evolve from every single task they perform. At first, they'll handle basic, repetitive processes, folding boxes, brewing coffee, tidying up. But over time, as their intelligence compounds, they'll begin running entire workflows, like managing a cafe, maintaining your home, or even coordinating complex operations without human micromanagement. Levine compares this evolution to the rise of coding assistants. Early tools could barely complete a line of code, but today they can write entire programs. The same is happening in robotics. Each new capability widens the scope of trust we place in machines. As robots demonstrate reliability, they'll be allowed to take on more autonomy, step by step, task by task, until one day we simply ask them to run the house, and they just do it. This isn't fantasy. It's the logical next step in AI's evolution. With every interaction, robots will refine their skills, guided by human feedback and their own growing understanding of the world. In single-digit years, Levine predicts we'll see machines performing real, valuable work in our daily lives.
So, in 1 year, we have robots which are like doing some useful things. Maybe if you have some like relatively simple, like loopy process, they can do it for you. Just like you got to keep folding like thousands of boxes or something. But then there's some flywheel, there's some machine which will like just run my house for me, as well as a human housekeeper would. What is the gap between this thing, which will be deployed in a year, that starts the flywheel, and this thing, which is like a fully autonomous housekeeper?
Well, I think it's actually not that different than what we've seen with LLMs in some ways, that it's a matter of scope. Like if you think about coding assistants, right? Like initially, the best tools for coding, they could do like a little bit of completion.
Yeah.
Like you give them a function signature and they'll like try their best to type out like the whole function and they'll maybe like get half of it right.
Yeah.
And as that stuff progresses, then you're willing to give these things a lot more agency. So that like the very best coding assistants now, like if you're doing something relatively formulaic, maybe it can like put together most of a PR for you for something, fairly accessible.
Right.
So I think it'll be the same thing. That we'll see an increase in the scope that we're willing to give to the robots as they get better and better. Where initially the scope might be like there is a particular thing you do, like you're making the coffee or something. Whereas as they get more capable, as their ability to have common sense and a broader repertoire of tasks increases, then we'll give them greater scope. Like now you're running the whole coffee shop.
I get that there's a spectrum, and I get that there won't be a specific moment that feels like we've achieved it. But if you had to give a year in which like that, your median estimate of when that happens.
I mean, my sense there too is that this is probably a single-digit thing rather than a double-digit thing. But the reason it's so hard to really pin down is because, as with all research, it does depend on figuring out a few question marks. And I think my answer in terms of the nature of those question marks is I don't think these are things that require profoundly, deeply different ideas, but it does require the right synthesis of the kinds of things that we already know. And sometimes synthesis, to be clear, is just as difficult as coming up with like profoundly new stuff, right? So I think it's intellectually a very deep and profound problem, and figuring that out is going to be like very exciting. But I think we kind of like know like roughly the puzzle pieces, and it's something that we need to work on. And I think if we work on it and we're a bit lucky and everything kind of goes as planned, I think single digit is reasonable.
Okay, I'm just going to do binary search until I get a year. Okay, so it's less than 10 years, so more than 5 years? Your median estimate. I know it's like a big range.
I think 5 is a good median.
Okay,
Yeah.
5 years. So if it can fully autonomously run a house, then I think it can fully autonomously do most blue-collar work. So your estimate is in 5 years it should be able to do most like blue-collar work in the economy.
So I think there's a nuance here, and the nuance is it becomes more obvious if we consider the analogy to the coding assistants, right? It's not like the nature of coding assistants today is that there's a switch that flips, and suddenly instead of writing software, suddenly all software engineers get fired and everyone's using
Right.
LLMs for everything, and that actually makes a lot of sense that the biggest gain in productivity comes from experts, which is software engineers, whose productivity is now augmented by these really powerful tools.
Yeah. I mean, separate from the question of whether people will get fired or not, a different question is just like, what will the economic impact be in 5 years?
Yeah.
The reason I'm curious about this is with LLMs, the relationship between the revenues for these models to their seeming capability has been sort of mysterious in the sense that like you have something which feels like AGI. You can have a conversation with it really passes the Turing test. It really feels like it can do all this knowledge work. It's obviously doing a bunch of coding, et cetera. But then the revenues for these AI companies are cumulatively on the order of like $20-30 billion per year. And that's so much less than all knowledge work, which is $30-40 trillion. So in 5 years, are we in a similar situation that LLMs are in now? Or is it more like we have robots deployed everywhere and they're actually like doing a whole bunch of real work, et cetera?
It's a very subtle question. I think what it probably will come down to is this question of scope, right? Like the reason that LLMs aren't doing all software engineering is because they're good within a certain scope, but there's limits to that. Right. And those limits are increasing, to be clear, every year. And I think that there's no reason that we wouldn't see the same kind of thing with robots, that the scope will have to start out small because there will be certain things that these systems can do very well, and certain other things where more human oversight is really important. And the scope will grow, and what that will translate into is increased productivity. And some of that productivity will come from like the robots themselves being valuable, and some of it will come from the people using the robots are now more productive in their work.
Productivity, just like wearing gloves increases productivity, or like, I don't know. But then it's like you want to understand something which like increases productivity 100-fold versus like wearing glasses or something which has like a small increase. So robots already increase productivity for workers, right? Where LLMs are right now in terms of the share of knowledge work they can do, which is it's I guess probably like 1/1000th of the knowledge work that happens in the economy LLMs are doing, at least in terms of revenue. Are you saying like that fraction will be possible for robots, but for physical work in 5 years?
That's a very hard question to answer. I think I'm probably not prepared to tell you what percentage of all labor work can be done by robots, because I don't think right now off the cuff I have a sufficient understanding of what's involved in that big of a cross-section of all physical labor. I think what I can tell you is this, that I think it's much easier to get effective systems rolled out gradually in a human-in-the-loop setup. And again, I think this is like exactly what we've seen with coding systems, and I think we'll see the same thing with automation, where basically robot plus human is much better than just human or just robot. Yeah. And that just like makes total sense. It also makes it much easier to get all the technology bootstrapped, because when it's robot plus human, now there's a lot more potential for the robot to like actually learn on the job, acquire new skills. It's just like,
because the human can label what's happening?
And also because the human can help. The human can give hints. Let me tell you this story. Like when we were working on the Pio5 project, this was the paper that we released last April. We initially controlled our robots with teleoperation in a variety of different settings. And then at some point, we actually realized that we can actually make significant headway once the model was good enough by supervising it not just with low-level actions, but actually literally instructing it through language. Now, you need a certain level of competence before you can do that, but once you have that level of competence, just standing there and telling the robot, okay, now pick up the cup, put the cup in the sink, put the dish in the sink, just with words, already actually gives the robot information that it can use to get better.
Right.
Now, imagine what this implies for the human plus robot dynamic. Like now, basically learning is not, for these systems, is not just learning from raw actions, it's also learning from words, eventually be learning from observing what people do, from the kind of natural feedback that you receive when you're doing a job together with somebody else. And this is also the kind of stuff where that prior knowledge that comes from these big models is tremendously valuable, because that lets you understand that interaction dynamic. So I think that there's a lot of potential for these kind of human plus robot deployments to make the model better.
And if this vision excites you, make sure to subscribe and like this video because the revolution of physical intelligence has already begun.